Okay, so this is the last of the videos this week, and then I don't know what day of the week you're watching these, but hopefully it's before Friday, because Friday we will chat and we'll go through any questions you have from these problems and get you all lined out for the Chapter 4 test. So this is a really simple little addition to the things that we've been yickety-yakking about so far, and that is congruence in right triangles. The nice thing about right triangles is they all have a right angle. And so that means you already have one thing that matches up. And so then all you need from there is two sides. And so the sides that we are going to use are the hypotenuse and the leg, okay? Now notice that if we knew that these two, like say I had two right triangles and I knew the two legs were congruent, then I know the triangles are congruent also, but that's from side angle side. This is a new triangle congruence because we have two sides, but the angle is not in between the two sides. And previously in that case, previously on Lost, we would have to have that angle in between the two sides in order for this to work. But again, since a right triangle is a special kind of triangle, then the angle doesn't have to be in between the two sides that we know. And again, the reason for that is because we could use the Pythagorean theorem to find this side right here. And since the numbers here would be the same, that means these answers would be the same also, and then we would know that these triangles are congruent by side, angle, side. So that's the proof that you're not going to have to do. Okay, so if we wanted to apply the hypotenuse leg theorem, well, obviously we need the hypotenuse and we need the leg. So we have a leg here, we would need to know this leg here, and then we have the hypotenuse there, so we need to know that hypotenuse as well. Short section. Write a proof using the hypotenuse leg theorem. If you insist. So we're going to try and show that this whole big triangle is isosceles. Okay, so I'm not going to go through jotting down all the givens because I don't want to. So we're just going to assume that those things have happened already. The other thing that I'm going to say is that AF is congruent to itself, and that is by the reflexive property. Okay, once I know that that's congruent to itself, now I have a leg of the right triangle. Then I just gave myself the hypotenuse of the triangle. So now I can say that triangle AEF is congruent to triangle ADF by hypotenuse leg. Then if I know that is true, now I'm going to jump down to these two little triangles down here at the bottom. If I know that these two big triangles are the same, then that tells me that these two sides are congruent. So I know that EF is congruent to FD, and that's by CPCTC. Okay, and I have this little guy down here. Oh, I guess I can't use 2 there because I already used 2 there, so I can just get 4. Okay, so then this is, I guess, a little bit tricky. I need to show now, can't really show that the sides are congruent because they're not in that triangle, but I can show that, these two angles are the same? Oh, got it. Over here, since this is a right angle, then this is also a right angle, and so is that guy. So now I can say that angles CEF and what's the other guy, BDF, are congruent, and that's because they're both 90 degrees, and I might have wanted to include another step there about those two things being a linear pair, and so then they add up to 180, and blah, blah. Okay, so then that means that little baby triangles are congruent. So CEF is congruent to BDF, and that again is the hypotenuse leg dealio, because this one, oh no, sorry, this one is the hypotenuse of each triangle, and this one is the leg. Okay, this is a little trickier than I thought, but we're almost there. So then that means that EC is congruent to DB, and that's again CPCTC. And then if AE is congruent to AB and EC is congruent to DB, then that means the whole things are congruent to each other by some like segment addition postulate or something like that. So AC is congruent to AB by, let's just write that down because that sounded fancy, so it must be right, segment addition postulate. And then that means that A, B, C is isosceles. Throw E in there to spell it right. And that's by definition. Okay, so that was a little tricky, but it sure was fun. Oh my lord, another one? Seriously? Okay, so now we're going to play again. Alright, so I know that these are two right triangles at the top, and I'm trying to show that what? J, K, M, so I'm trying to show the triangle on the right and the left are congruent. So again, I should write down all the givens, but I'm not going to. But I do know that angle JNK is 90 degrees. And that's because it makes a linear pair with the one next to it, which we know is 90, so that means it has to be 90. I know that Kn is congruent to itself. Again, that's the reflexive property. Therefore, I know that triangle JKN is congruent to LKN by hypotenuse leg. Okay, where do I go from there? So that means that JN is congruent to NL by CPCTC. Okay. These are also right triangles because, you know, you could say vertical angles. So I know that this is the right angle, and I know that that's the right angle, and I know that that's the right angle, and we know that these two are congruent to each other. I'm going to say this guy is congruent to itself. Let's get back to our little text here. So I'm going to say that NM is congruent to NM. That's the reflexive property again. So that gives me that triangle LNM is congruent to triangle JNM. Notice, even though this is a right triangle, we're not using hypotenuse leg because I don't know the hypotenuse here. I just know these two legs. So I'm just going to call that our old friend side angle side. And so that tells me that JM is congruent to LM by CPCTC. So now I know that this side and this side are the same. This is the same as itself. So we'll call her good and say that the two triangles that we were asked to prove congruent are congruent. JKM is congruent to LKM And that is by side, side, side. Okay, donezo. So that was kind of a mess, but proofs happen sometimes. So there you go. All right, so there's your last assignment, a few problems to work on, and then we will get together tomorrow morning or whatever, Friday morning, and go through your questions on those.